Hey everyone, it's me, Ray Long, and this is another episode of Full Stack Distributed Systems. Tonight we're going to keep working on our Unity project. We're going to be starting here in just a moment. But before we do, be sure to check out the links below, subscribe and like. I don't want to spend too much time, but more importantly than you checking out those links, just know that I just want to say thank you. If you're watching this video, I just want to say thank you. I don't care how you got here, Patreon, YouTube, early access, 2-week delay, pay to play, free to play. It's all free to play in the end. And no matter how you got here, you're helping me out. If you're a subscriber, or you're a patron, or you're a student, either way you look at it, I'm very, very grateful to have you guys here. Alright, so we're going to get right into it. We're going to review what we got going on, so let's get into it. Okay, so we're looking at Unity here, and we've already done some work. Okay, we've updated our prefabs folder. We've made a dice roller prefab and a BaseCharacter prefab. We've updated our scripts folder. We now have a character package or module or namespace, whatever you want to call it. We have it now. It's going to be its own set of concerns. We're going to basically create a base character, and other player characters or other models or other non-playable characters or whatever you want to call it, they're all going to descend or inherit from this base character class that we create. Okay? So why don't we go ahead and look at the inspector here for a bit. Or maybe not. I think maybe Unity has crashed on me. Let's jump into the code. Yeah, we'll jump into the code. Okay. So we have our base character. Let's get into our base character. And we have an array of modifiers. It's going to be an array of game objects. We have special abilities. Those are going to be an array of game objects. Now, we may want to get a little more specific in our type system a little bit later. Simply for the fact that a game object in Unity can be just about anything. I mean, that's about as precise as casting everything to object in the Java world. You can do it, and there are use cases where you want to do it, but in my philosophy, what I'm calling next level engineering, we want our type system to be as precise as possible. We want our class hierarchies or our type hierarchies to be concise and as unnecessarily complex. Excuse me. Quite the opposite of unnecessarily complex. We want it to be as simple as possible. We want to remove all unnecessary complexity completely and thoroughly. Down to every last line of code, every last comment, every last name, every last type, every last everything. It's got to be simple. It's got to be descriptive. It's got to be lucid. And it should be immediately obvious what the hell's going on. I'm kind of happy with what we've done with the modifiers property. So we have getters and a setter. These are the accessors, right? And the getter is interesting because what it does is it returns a new stack of game objects with the modifiers. With the modifier array that we expose in the field. So this means that whoever is consuming the stack of modifiers, whether getting it or setting it, they're going to tack on, or rather they're going to deal with all of the array of modifier game objects as a stack. So that's last in, first out. Think of it like the bottom. This is a weird song. Removing this from the playlist. whatever. I'm just trying all sorts of different music for the videos, you know, whatever you guys like. The real challenge is finding music that I can legally license without having the videos pulled. Alright, so anyway, anybody who wants to consume our modifiers is going to have to consume a stack. It has pushing and popping semantics. It has 2 array semantics, as we can see in the setter. It's all very nice. Our base character, none of these things should be called on the actual base character itself. Okay, what we're actually going to want to do is we're going to want to inherit from base character and then override all of these. So we may want to put virtual on here. And hopefully that doesn't break the interface contract. No, it doesn't. So we could actually make these abstract. I can hear some of you thinking that. Why doesn't he just make it an abstract class? Well, there's a little bit of... I actually want the behavior to be an exception, a not implemented exception, if somebody tries to do this with a base character. I mean, it's wrong behavior, and yeah, it should be implemented. So, and then the developer who is working with the code will know that they need to implement their own version of this class, or at least their own descendant of it, right? So let's go ahead and save this. So we haven't really gotten into how we're going to organize our armies in our universal wargame engine, but the thing about agile development is we oftentimes work with a lot of unknowns at the time that we're working with them, you know? We often don't know exactly what's going to go on until it actually happens, and that's okay. So if we avoid over-engineering our solutions today, our code will be very easy to refactor. Like, you'll see that I keep things pretty minimal. I don't put a lot of time into these early stages and getting all sorts of logic and rules implemented. What I'm trying to do is flesh out the whole skeleton of the system, and then I'll implement each piece of it, each subsystem as we go. Right? I think that's a good way to proceed and to carry on. Okay, so we need some kind of character. What the hell is this music? Oh, this is called Introspective Spacewalk by Asher Fulero from the YouTube audio library. Some weird shit, like it. You know what? Let's add a new folder. We're gonna call this command hierarchy. Okay. And basically what's gonna go in here is we're gonna put in our different types of characters. So let's add a I don't want to do it there. I'm going to pop over to Unity real quick while you're not looking. And I'm going to create an empty C# script, and we're going to call it a grunt. Okay. And we'll deal with that grunt. Just reload this Visual Studio project real quick since I made a change to it over in Unity. Okay, now I have command hierarchy. This should have stuff in it. I don't know why it doesn't. Let's reload the solution. Sometimes you got to do that. You may have done things out of step a little bit. It just occurred to me that on our base character we're going to want to add points cost. Or cost. So let's go to our base character for a second. And why don't we go ahead and put public int cost. Why don't we default to 2? 2 seems good. See, we'll add a comment. Most war games use a point by system to turn models into units on the battlefield. There we go, right? Make sure OBS is on the right screen. Okay, good. I don't want to be fucking around here. Alright, well, we're going to want this namespace, right? In fact, why don't we just grab this? Go to Grunt. Yes, you're a Grunt. A character dot command hierarchy. Oh my goodness. Isn't this fantastic? You know what we should do? We should be good developers, and we should add some comments. There we go. Dice roller. Interface contract. Prefer this to any implementation. Mission when possible. That's a good comment. Alright, what about dice roller? You can add a comment here. Dice roller implementation of iRoller or iDice roller. Form of a unity or a game object. Okay, that's good. Let's see, we're doing BaseCharacter. Let's see, BaseCharacter interface and contract. Prefer reference by interface type instead of
any ideas?
What did I write in the other one? It was so much more elegant. See? Why am I trying to reinvent what was so nice from just a second ago? Sorry about all that noise, ladies and gentlemen. I got a little bit of that nurgle rot in my lungs. Okay, we got some real nice comments here. Music's kind of fruity, but we're gonna go with it. Honestly, I don't mind. I kind of like weird stuff like this. Okay, base character implementation of BaseCharacter as a pretty specific. Oh, we're taking a drastic turn here. Alright. First off, we want BaseCharacter. Yep. And we're going to probably have to implement well, let me fix it. Let's jump to BaseCharacter. Alright, well, we'll call this public. We need to have similar access levels, or at least they have to cascade in the right direction. That'll all be... Yeah, there we go. Okay. The most basic model on the battlefield. Okay. There we go. You can auto hide the solution and the properties. Here we go. It's a little more effective. Okay, so what do we need here? Let's head back over to Unity for a moment. We have a base character. We probably don't need to have this as a prefab, but what are you going to do? Okay. So we're going to call this a grunt. You know, we can have this and have it just be inactive. We'll call this a grunt. But again, we should be able to copy this, right? Okay. We're going to add a grunt. And we can see in Unity we have our fields exposed. Now let's hop back over to Visual Studio. And we will see that our grunt has these fields exposed, despite the fact that we don't see them, because they're in our base character definition. This music is really soft and subtle. It's a song called Deep Horrors. Alright. So we're looking at the code here. What do we want to do? Let's go back into Unity. Jump over here. And let's make a grunt prefab. That seems like something that we're going to want to do. We want a grunt. Right? I think so. Yeah. Yeah. And we have our grunt. What can we do with it? We need to do something with our grunt. Right? Sinister music is informing me that we should be either working on his abilities or his ability to do combat. Oh, I don't want this. Why did I open this? It's ridiculous. Oh yeah, okay. Let me just take a look at OBS. Alright. Yeah, so let's take a look at the code for our grunt and see which portions of it we want to start implementing. Because then we can add some elements to the UI. As you remember, we set up no parameter methods that return void. So we will be able to easily call them from the UI once we implement them. So let's switch back to Visual Studio. And let's say, let's do death sequence. Public override void death sequence. We don't want to call base No. This will throw the exception. Throw the... Oh yeah, I like the song. In the base class. Alright, so what are we gonna do? Well, let's write to the logger. You know, start telling a story. Say, this name has died. Right? Fantastic. Okay. Let's go back to Unity. And let's add a kill button. Let's create a button. Right here on the canvas, we're going to call this kill button. Right? And kill button needs to have a label. And it's going to say, kill my target. Oh no. Kill button. Wow, that was almost really dumb. Kill my target. Okay. Fantastic. Now let's go in the scene. We're going to move this button. No. We want to move the button. I'm thinking... killing my target. Oh, scratching my face on the mic. My beard, I gotta shave it tomorrow morning. I'm sure that sounded wonderful. Alright, prefab. Why don't we update this canvas? I like doing that. Why don't we save everything here? And now, for fun, we're still in Unity, in OBS. Fantastic. Let's go ahead and start this up. And we're gonna roll the dice a little bit. And then we can go ahead and, our dice keeps failing. Let's clear the logs, and now let's go ahead and kill my target. You know what? We forgot to actually wire it up because we're so awesome. Of course. Of course, of course. Grunt. Death sequence. See that? Now we can call the death sequence. So let's go ahead and do this. Let's roll that dice. Let's go ahead and clear this. Let's kill my target. Grunt has died. Grunt has died. Underscore Grunt has died. Fantastic. You see that? That is fantastic, ladies and gentlemen. And we're not even a half hour in. So think about what we've done. Since we're trying to keep our type system clean and our code clean and all of our components broken up into their orthogonal components with their, containing their own concerns, we're able to quickly extend our slowly developing system here piece by piece with confidence. We can start adding new components to it with a high degree of certainty that we're not going to break other stuff. Which means we can spend more time being productive and less time fixing bugs. Isn't that fantastic? It's so fantastic, in fact, that this skill alone, okay, I'm telling you as someone who's experienced in the field, earns his living this way, This skill alone, on the technical side, combined with charisma on the social side, will position you to have a long and rewarding career. That's all I'm going to say. I don't want to promise you anything that you may think you deserve. Go out and make it happen. But I'm telling you, on the technical side, being able to boil problems down into simple rules that you can implement with a simple code base that you can extend is going to make you so productive that you're going to be in high demand by people who want to pay you very comfortable salaries, okay? So, again, we saw how easy it was to extend this, and we were just going at a slow pace so we could talk about it a bit. I mean, you know, we're not even a half hour into the recording, and we cranked out this feature, but had I not been talking to you about it as we went, I would have done it easily half that time, you know. I could be cranking out a few more buttons on this UI that do useful things in a matter of time, you know? In a short matter of time, rather. So again, simplicity is the key. I'm going to keep driving it into your head like nails into the base of your brain. The base of your brainstem, okay? So important. Just get this in at the root. Simplicity, simplicity, simplicity. Okay? It's the key. It's the key to maintainable software. It's the key to being employable as a software developer. Simplicity. Simplicity means maintainability. And it means enhanceability. Okay? All of that with confidence. Well, we have some other stuff to do, you know, in the future. In the not too distant future. We're going to have to work on the UI a bit. We're probably going to want to maybe group these into panels and maybe add some graphics or some textures and maybe just kind of spice this up a bit. Maybe we'll put a wallpaper behind there that we'll design, maybe in GIMP or something. You know, that'll be fun. We could add a GIMP graphics tutorial into the video. But anyway, let's get back into Visual Studio and let's think about the next features that we're going to add to our code base here. What are we going to implement next? All right. So we did a death sequence, okay? And let's see. Hit sequence is a bit ambiguous now that I'm thinking about it. Because is this when the character gets hit, that sequence? Or is this when they hit their target? Is it that sequence? So, it'll be interesting. Okay. Let's make a region here in our code for readability. We're going to call these BaseCharacter overrides. So in C# you can implement multiple interfaces, but you can only inherit from one class. So, okay. So we're going to do this. Instead of death sequence, we could do we have we don't have a spawn sequence? Let's add that. Death sequence, we need a spawning sequence. Alright, and then BaseCharacter is gonna need to implement that method, right? So let's go ahead and implement that interface. Okay. Now let's go back to our grunt. Public override void. Let's do our spawn sequence. Yes. We need to make spawn sequence virtual so it can be overridden, of course. Okay. Again, we don't want that. We'll leave the other one as an example. We don't need to keep repeating ourselves, right? So let's be fucking goddamn professionals about this, alright? So this dot name has spawned at let's see. Let's do public transform starting position. This could be null, so what do we want to do? Well, let's go look at the definition of transform. Or at least let's see what its, its contract looks like. Let's go to its definition. Okay, so it's a component. Don't think, yeah, we can't create a transform, but it's a little more upbeat. Alright, let's do this. Can we create? Oh, we can instantiate. Call game object.instantiate on transform sometime today. Alright, garbage collector, don't fail me now. Damn. Well, how many arguments does it take? Can they just do... Oh, this is so crazy. Alright, let's rethink this a little bit. I don't want to go down the rabbit hole of recursively having to get transform after transform after transform. So, what about this dot? Transform. What? Alright, well, that makes sense. So here's what we're gonna have to do in order to not be total assholes. Go into our start. What does start look like? It's just void start, right? Okay, here we go. So, starting position will equal this game object.transform, right? Okay. And then we want to tell a story about this. So let's go and add a logging statement. This not name plus starting position. We call base.start. Can I do virtual void start? And then call no. Why doesn't it like this? So I'm wondering if start is going to do its thing. Okay. Save all of this. And we are going to jump back over into Unity. We're going to see what the logs look like when we start this beast up. We know Grunt could die. We'll kill Grunts all day. Doesn't matter. That's what we do. Alright. It's not looking good from a Grunt. Starting position is none, so it didn't call the base start. So that's fine. So here's what we want to do to fix that, right? Let's go into OBS. Let's take this. We're going to take all this right here. Let me just make sure that everyone's looking at the right screen. Okay, good. And let's just transport this into here. In fact, better yet, can we... is there a way to quick actions and refactorings? What do we got? Man, I need to get ReSharper on here, because ReSharper is amazing. It has so many great refactorings in it built into the tool. Like, I should be able to right click on this selected block of code right here, these expressions, and pull them out into their own function. And then automatically tell it to pass in starting position in these two things to make the parameter, right? So we can actually make a helper method. This is actually a good use case for a static helper. Let's call util. Can I just add a blank C# file? That'd be great. Do we have empty or blank? Code file. going to call this transform helper. Instead of dice, this is going to be util. Character, right? Instead of character, yeah, it's going to be util. Oh no, it's not good. Do some funky ass shit's going on over here. Alright. So, public, static class. Transform helper. So static classes, we don't have to instantiate them. We just simply access their members using dot notation. Oh, everything's all good. I was just hearing shit. Alright, so public. We're in a Unity engine. And maybe system and collection is generic too. Probably not right now, but we might use it later. Alright, so let's make a method that returns a transform. That's going to be set transform value. Change my code style, who knows? Actually, why don't we make this a void for now? We gotta make this method static too. Of course we do. The class has to be static and the method has to be static. So we're gonna say, holy shit. Oh yeah, of course. So we're gonna have transform target. Oh wait a minute. Set transform value. Target to set. Transform from value. There we go. That seems pretty reasonable. I already have my okay. I do. Okay. Set transform value. From value. Target. Just say to target. From value. There we go. Now it kind of reads like a story, right? Like we say, set transform value to target from value. That's exactly what we're going to do. Let's see if this works. We may have to pass this in by never mind, we don't want to get too confused. Let's not worry about that right now. Don't think this is gonna work. Don't think this is gonna work exactly how we think it's gonna work by looking at the code. So let's go over here and how we think it's going to work. Let's go back to Unity and add some UI elements. So let's take this button, and again we'll clone it. We'll copy it and paste it. And we'll rename this the spawn button. This will invoke the spawn sequence. Sounds pretty gross when you talk about it, but we're just talking about code. Spawn a target. Oh, it all sounds so violent. Okay. Now the button, let's make sure it has the right event attached to it. We don't want the death sequence, we want the spawn sequence. Okay. Now let's go ahead and run the game. Okay, we started the dice roller. Roll the dice still, that's fun. Let's clear the logs. We can kill the grunt has died. Okay. The grunt has spawned at what? So we have nothing in there. Exactly. Huh. So it has the starting position of itself. See, we want to copy the value. We don't want the reference. Let me see something here. C# by reference versus by value. By default, all parameters in C# I believe are passed by value. Okay, let's see. Yeah. So what we probably need, the target probably needs to be the left-hand side of the equal sign. Alright, let's go back to Visual Studio. The left-hand side of the equal sign, just like I kind of thought, we probably want to pass that by reference into the it's overwrite. It's okay. It happens. Now, passing by reference is generally regarded to be a bad idea, but this is the realm of game development where most conventional bad ideas actually find a way to be good ideas. Okay, so why don't we go into the definition of set transform value, and we'll go ahead and we're going to pass this by reference. Ah, boy. To target. Wait a minute. To target? What is to target? Oh yeah, we want to pass to target by reference as well. I actually want to pass that by value. Yeah, that's fine. Otherwise, okay. Let's go back to Unity. Let's see if we made a little progress on this wackiness. Clear out the console. Grunt CS, line 2023. Grunt CS, line 23. Oh, let me see. Property or indexer may not be passed as an out or ref parameter. Alright, so that's actually not going to work the way we thought it wasn't going to work all along. Fantastic. It's going to do nothing. This is a bit of a tricky problem. Music goes all over the place here on this show. Let's go back into Visual Studio. You can't necessarily. Wait a minute. I actually think this did seem to work. Let's go back for a second. I don't think I like this sound. Okay. Oh. See what's going on here is these are backwards. I know that's right. Oh, well. The reason that debug log statement sucked is because it didn't actually do anything useful. It didn't actually log the transform value. Oh, that's getting foolish. That might be a sign that we might be almost done for the evening with our mini hackathon here. We didn't actually officially call it our hackathon, but that's what it turned out to be. And I think we're going to want to add some more stuff here. Start this up. Are we in, okay, you see what I'm seeing here? Okay, let's try an experiment. Let's see if this resawns it. So this to 100, it does nothing. Okay, so it did not reset, okay? That's a bad implementation. So we're gonna go fix it real quick before we end this video. What if we just do this in reverse? We'll say transform equals starting position, right? Should work. That's a get. Okay. What about game objects? Oh, I see. Okay. Oh my goodness, I see. So we don't actually know how to transform it right now. Okay. Damn. Interesting. Okay. Well, we actually don't know. Reset starting position. I'll have to look that up. Okay. Alright, everyone. We spent time here tonight working on our BaseCharacter implementation. And so far it's going pretty well. We've seen how easy it is to extend a clean architecture, clean components. And that's really where we're at. So we'll keep working on this in future videos. Thanks for watching. Thanks for checking out. Subscribe below. And as always, thank you for your time.